Today's lesson is on graphs of nonlinear equations and interval notation. So first we want to introduce you to the Cartesian coordinate system, which is just like a fancy name for the XY plane, which many of you have seen before, but maybe didn't know it was called the Cartesian coordinate system. We use a rectangular coordinate system to help us visually display relations, which we'll be talking about fairly soon. The horizontal axis is the x-axis, and that's this axis right here. We'll highlight it in red. The vertical axis, that one is the y-axis, and we'll highlight that one in blue here. Okay, so that's the y-axis. The point at where the x and y-axis intersect is called the origin. And that's right here. Okay. And then we used ordered pairs to communicate a location on the coordinate system, or we call that often x, y. The first coordinate, or x, is the horizontal distance away from the origin, and the second coordinate, or y, is the vertical distance away from the origin. So we use these x, y's to show where a point is on the graph. So for the first point, a is equal to 1, 4. My x-coordinate is 1, my y-coordinate is 4. So starting from the origin, I'm going to go in the x direction, a positive 1, which is 1 to the right. And in my y direction, I go 4 in the positive direction, which is up. 1, 2, 3, 4. That location, notice that I didn't put my pencil down until I actually got to the 1, 4 location. That location is point A. Let's do B in red. So the x-coordinate is 0, the y-coordinate is 2. So starting again from the origin, all points originate from the origin. So I'm going to go left and right 0 and up 2. A lot of students have a hard time with the zeros. They, for some reason, go the opposite direction. So be careful with ones that have zeros in them. The next one we'll do in green, I guess. So in this case, we have our first negative. So going back to the origin, I'm going to be going left 3, because negative 3 in the x direction is to the left, positive is to the right. So I'm going to go left 1 to negative 3 there. And then positive 5 in the y direction, that's an up. 1, 2, 3, 4, 5. So that's going to go right there. And we'll do one more, and then I'll let you practice. So on the next one, negative 4, 0 goes 1, 2, 3, 4 in the negative x direction, and up and down 0, so it stays right put on the x-axis. Alright, why don't you go ahead and pause the video and see if you can't do the next 3 on your own. Okay, check your points E, F, and G. Hopefully you got the same points I did. And now we'll move on to our next example. In this case, I give you the plotted point, and I want you to write the associated ordered pair. So the first point is right here, that's A. Okay, so I want to go left and right how many from the origin? Well, I want to go straight up. I don't want to go left and right any. So my first ordered pair in the x direction is 0, comma, let's count that. 1, 2, 3, 4, 5, 6, 7. Looks like 7. Okay, so my next ordered pair is right here. Again, that's in the positive x direction and in the positive y direction. So from the origin, I'm going to go 1, 2, 3 to the right and up 1, 2, 3, 4, 5. Point C we'll do here in purple. So we are going from the origin right 1, 2, 3, 4, 5 to the right. And it looks like we're going to go down 2. So that would be a negative 2, because in the y direction, negative is down and positive is up. Go ahead and pause the video and see if you can't find the points D and E by yourself. Okay, so hopefully you got point D to be 0, negative 4, and E to be negative 3, negative 1. If not, go back and check your work. Moving on, we can use the Cartesian coordinate system to graph solutions to equations in two variables. Equations in two variables have an infinite amount of solutions. So we can't actually write them all down, but we can visually represent them in a graph on the coordinate system. So for example, 3x plus 2y equals 12 has an infinite number of solutions. Let me just show you a few. 2, 3 is a solution. It truly is. And let me show you why. Because 3 times 2 plus 2 times 3, is that truly equal to 12? Well, let's work it out. 6 plus 6. Yep, that truly does equal 12. So 2, 3 is a solution. The next one says 4, 0 is a solution. Well, why? Well, when I substitute 4 in for x, and when I substitute 0 in for y, does that truly equal the right-hand side, which is 12? Well, let's find out. 12 plus 0. Yep, truly does equal 12. So 4, 0 is truly a solution. Let's do one more. 3 times x, but in this case, x is 0, plus 2 times y, but y is 6. Is that truly equal to 0? Well, let's find out. 0 plus 12 equals 12. It does work, okay? So therefore, here are 3 solutions. And as I said earlier, there's not just 3. There's an infinite amount of solutions on this graph. So I want you to graph 3 solutions on the coordinate grid. So, and the light blue one was positive 2, positive 3, which is the same plotting that we just practiced. The red point was 4 to the right, 0 on the x-axis. And then the green one was left and right 0 and up 6. 1, 2, 3, 4, 5, 6. There we go. Okay. So those 3 points are all solutions to the line 3x plus 2y equals 12. Now, notice that the graph is, the points are collinear, and if I connected them, it would make a straight line. So let's go ahead and connect those. We call equations that produce straight lines linear equations. So this is a linear equation. Clearly I only graphed 3 points, but every other point on this line that I didn't actually plot individually are all more solutions to that equation. 3x plus 2y equals 12. Every point on that line will solve that equation. Again, we said that there's infinite amounts of points that solve that equation, so many so that I can't write them down, but if I draw a couple points and connect them with a line, then I can show you all the representations, because this little arrow says it keeps going forever. So that is a visual representation of all the infinite solutions. That there's so many I can't write down, but I can sure show you on a graph. Alright, so let's keep going. Linear equations will have x and y variables without any exponents or radicals. So, using that definitions, x and y intervals without any exponents or radicals. Which of the following here are linear, meaning it produces straight lines? Let's take a look at the first one. The first one has this little x squared here. This says the x and y won't have any exponents, so that's not going to be a linear equation. This one has an x and this one has a y. There's no exponents and there's no radicals, so this one's going to produce a linear equation or a straight line. The next one, y equals the square root. Well, already, any radicals, we're going to have to say that's not going to be linear. How about x minus 9 equals 0? There's an x value, there's no y value. But that's not going to exclude it from being a linear equation. The only thing that excludes it if it has exponents or radicals in it. So this is a linear equation. Even though it doesn't have a y, it's still a linear equation. How about the next one? Y equals 5. Again, there's no x, but there's no radicals and there's no exponents, so we're going to include it as a linear equation. Y squared plus 2x squared equals 5. Nope. X squareds, eliminate it as being a linear equation. Now we will learn how to graph all of these equations, but I just want to make sure you understand what is a linear equation and what is not.